Hey everyone, and welcome. We're always hearing about how amazing AI is, right? But have you ever really stopped and wondered how we grade it? I mean, how do we know if a machine is genuinely smart or just, a lucky guesser? Today, we are going to pull back that curtain and look at how we actually judge AI.
It really all comes down to this one simple question. You hear an AI can predict the stock market, or spot diseases, or filter your spam. But honestly, without the right way to measure it, that's all just talk. So, how do we get a score that we can actually believe in?
Well, the very first step is figuring out what kind of problem the AI is even trying to solve. Think about it like this. You wouldn't use a measuring cup to see how long a table is, right? It's the wrong tool for the job. In the AI world, there are pretty much two main jobs. The first is categorizing stuff, like, is this email spam or not spam? The second is predicting a number, like, what's the final sale price of this house going to be? Each one needs a totally different tool to measure it. So let's start with that first tool. This is the one we use for problems that have a really simple right or wrong answer. And this is where we get to talk about the metric that probably pops into your head first, accuracy.
And the definition is just as simple as it sounds. Accuracy is just the percentage of times the AI got it right. It's clean, it's easy to wrap your head around, and it gives you a nice, straightforward score of the model's overall correctness.
Yeah, this quote just nails it. It's the first question anybody would naturally ask. Okay, so how often does it actually get the right answer? That's probably why it's such a popular metric. It just makes intuitive sense.
And this shows you exactly how it works. Let's say we have a spam filter, and we test it on 100 emails. It correctly spots 40 of them as spam, and it correctly lets 50 normal emails through. You add those up, 40 plus 50 is 90 correct predictions out of 100 total emails. So boom, its accuracy is 90%. Simple, right?
And you see that 90% score and you think, wow, that's great. It's an A-. It feels like the model's doing its job really, really well. You'd probably trust it, wouldn't you? Well, this is where our story takes a little bit of a turn.
Because that super high score, it can be incredibly misleading. There's this hidden trap with accuracy, a really dangerous flaw where getting a fantastic grade actually means you've failed the test completely.
Okay, so let's switch to a different problem, credit card fraud. Now, in the real world, fraud is, thankfully, pretty rare. So you might see a data set where maybe only 5% of all transactions are actually fraudulent. That means 95% of them are totally normal. And that imbalance, that's the key to everything.
Now picture a really, really lazy AI. So lazy it doesn't even try. Its entire strategy is just to predict that every single transaction is normal. It never ever flags anything as fraud. So what kind of score do you think this completely useless model gets?
It gets 95% accuracy. Yep, because 95% of the transactions are normal, it gets to be right almost all the time just by guessing the most common answer over and over again. A ridiculously high score for doing nothing useful at all.
So here's the billion-dollar question. The model scored a 95%, but what was its one job? It was supposed to find fraud. So how did it do?
Zero. A big, fat zero. It finds absolutely no fraud. And this just perfectly shows the danger, right? You can have a 95% accurate model that is a complete and total failure. So whenever you have a situation where one category is rare but super important, like finding fraud or a rare disease, accuracy isn't just a bad metric, it's a deceptive one.
So if accuracy is the wrong tool for that job, let's look at our second type of problem, predicting a number. For this, we need a totally different tool, one that measures not if you're right or wrong, but how close you are. And this is where a metric called RMSE comes into play.
RMSE, which stands for root mean squared error, is basically a ruler. It measures the average distance, or the error, between what the AI predicted and what the real value actually was. So a lower RMSE is better. It means your model's predictions are, on average, a lot closer to reality. And here is why this is so incredibly useful. The result you get from RMSE is in the exact same units you were trying to predict in the first place. So if you're predicting house prices in dollars, your RMSE is in dollars. If you're predicting temperature in Celsius, your error is in Celsius. It makes the result instantly easy to understand.
Now the calculation might look a little scary, but it's actually pretty logical. First, you just find the error for each prediction, the actual value minus the predicted one. Simple. Next, you square that error.
This is a really clever part, because it punishes big mistakes way more than small ones. Being off by $10 gets penalized a lot more than being off by 2. Then, you just average all those squared errors. And for the final step, you take the square root of that average, which just neatly brings the number back into the original units you started with, like dollars or degrees.
So what does this mean in the real world? Well, if you have a model for predicting house prices and its RMSE is $5,000, that tells you something super clear. It means that, on average, the model's predictions are off by about $5,000. See? Instantly useful information.
Okay, let's bring this all home. We've looked at two very different kinds of problems and two very different tools for judging how an AI is doing. And really, it all comes down to picking the right one for the specific job you have. This right here is the perfect summary. You've got accuracy, which is for classification, sorting things into buckets. It answers the question, how often is it right? But its fatal flaw, its kryptonite, is imbalanced data. Then you have RMSE, for regression, predicting a number. It answers, how far off is it? Its main weakness is that a few really huge errors, what we call outliers, can really throw off the final score.
So, here's the bottom line. The metric has to match the problem. Use accuracy when your categories are pretty balanced, like telling cats from dogs if you have about the same number of photos for each. And use RMSE when you need to predict a number, like a price or a temperature. If you choose the wrong metric, you don't just get a bad score, you get a totally false story about how your AI is actually performing.
And that's what we want to leave you with. Every single time you see a number, a statistic about an AI's performance, just remember that that score is telling a story. And it's on us to ask, is it telling the right one?